I am Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. Today in sequence and series, I will teach you new topic, that is ratio test and Raabe's test. So let's start. First of all, we will see what is the statement of a ratio test. This is also called D'Alembert's ratio test. If sigma n is from 1 to infinite un is a positive term series and limit n tends to infinite un plus 1 upon un, that is equals to L, then first one, for L less than 1 the series converges. Second one, for L greater than 1 the series diverges. Third one, for L equals to 1 the test fails. So this is the statement of ratio test. Now you have to note down the important point. The series that involves factorials or other products, including a constant raised to the power n, are often conveniently tested by using the ratio test. Now we will see some examples related to this topic. Test the convergence of the series sigma n is from 1 to infinite 2 raised to n upon n factorial. Here un equals to 2 raised to n upon n factorial. Therefore un plus 1, that is equals to, replacing n by n plus 1. So we have 2 raised to n plus 1 upon n plus 1 factorial. Now L equals to limit n tends to infinite un plus 1 upon un. This is equals to limit n tends to infinite, and this is un plus 1 upon this is un. Now we will simplify this result. So 2 raised to n one time will cancel out and we have 2 over here, and then after writing 1 upon n plus 1 factorial upon 1 upon n factorial as n factorial upon n plus 1 factorial. So limit n tends to infinite, this 2 will be as it is, writing n factorial as it is, now writing n plus 1 factorial as n plus 1 into n factorial, because 5 factorial, that is nothing but 5 into 4 factorial. Now n factorial and n factorial will cancel out, so we have limit n tends to infinite 2 upon n plus 1. Now as n tends to infinite, 1 upon n plus 1 tends to 0, 2 into 0 is 0, which is less than 1. So by ratio test, series sigma n equals to 1 to infinite 2 raised to n upon n factorial is convergent. Now this is the example. Is the series sigma n from 1 to infinite n is to n upon n factorial convergent? So here is the solution. Here un is n is to n upon n factorial. Now we will find out un plus 1. So for that purpose we will replace n by n plus 1. So this is un plus 1 and that is equals to, replacing n by n plus 1. So it will become n plus 1 the whole raised to n plus 1 upon n plus 1 factorial. Now we will simplify this result. This is n plus 1 the whole raised to n into n plus 1, and this n plus 1 factorial is n plus 1 into n factorial. So n plus 1 will cancel out. So the final result is n plus 1 the whole raised to n upon n factorial. This is un plus 1. Therefore L equals to limit n tends to infinite un plus 1 upon un. Now we will divide un plus 1, this one, by un, that is this one. So n factorial and n factorial will cancel out. So we have limit n tends to infinite n plus 1 the whole raised to n upon n raised to n. Now taking n common from the numerator, so we have n raised to n into bracket 1 plus 1 upon n the whole raised to n divided by n raised to n. So n raised to n will cancel out from the numerator and denominator. So we have limit n tends to infinite 1 plus 1 upon n the whole raised to n, and this is nothing but the standard limit and its value is e, which is greater than 1. Therefore, the given series is divergent by ratio test. Now we will see this example. Test the convergence of the series sigma n is from 1 to infinite 2 raised to n upon n cube plus 1. Here is the solution. Here un equals to 2 raised to n upon n cube plus 1. So first of all we will find out un plus 1. Replacing n by n plus 1. This is equals to 2 raised to n plus 1 upon replacing n by n plus 1. So it is n plus 1 the whole raised to 3 plus 1. Now L equals to limit n tends to infinite un plus 1 upon un, and this is equals to limit n tends to infinite. This is un plus 1 upon this is un. We will write down 2 raised to n plus 1 as 2 raised to n into 2 raised to 1. We will take n cube common from this term, and from the denominator of this term we will take n common. So therefore L equals to limit n tends to infinite. We have 2 raised to n into 2 raised to 1, n cube common, so into bracket 1 plus 1 upon n cube upon 2 raised to n common from the bracket n plus 1 the whole cube, so it will become 1 plus 1 upon n the whole raised to 3, and then after taking n cube common, so it will become n cube into bracket 1 plus 1 upon n the whole raised to 3 plus 1 upon n cube. Now we will simplify this result. Now here 2 raised to n will cancel out, n cube and n cube will cancel out, and after simplification we will be having these two terms in the numerator and we will be having this term in the denominator. Now we will apply the limit as n tends to infinite, 1 upon n tends to 0, so definitely 1 upon n cube tends to 0, so we have 2 into bracket 1 plus 0. So this is 1 and 1 into 2 is 2 and divided by 1 plus 0 the whole raised to 3. So it is going to be 1 plus this is 0, so 1 plus 0 is 1 and the overall result is 2 and which is greater than 1. So by ratios test series sigma un is divergent. Now we will see next test, that is Raabe's test. If sigma n is from 1 to infinite, un is a positive term series and limit n tends to infinite n into bracket un upon un plus 1 minus 1, this is equals to L, then first condition for L greater than 1 series converges, second condition for L less than 1 series diverges, for third condition for L equals to 1 test fails. So this is the statement of Raabe's test. Now you have to note down the important point, that is whenever ratio test fails, that is L equals to limit n tends to infinite un upon un plus 1 or limit n tends to infinite un plus 1 upon un equals to 1, then we have to apply Raabe's test. Now we will see one example related to Raabe's test. Is the series sigma n is from 1 to infinite 4 raised to n into n factorial upon 2n factorial convergent? So here is the solution. Here un equals to 4 raised to n into n factorial upon 2n factorial. So therefore un plus 1, that is equals to replacing n by n plus 1 in un. So this is equals to 4 raised to n plus 1 into n plus 1 factorial into n plus 1 factorial divided by 2n plus 2 factorial, because if you will replace n by n plus 1, then after you have to multiply it by 2, so it will become 2n plus 2 factorial. Therefore L equals to limit n tends to infinite un plus 1 upon un, and this is equals to limit n tends to infinite, and this whole expression is un plus 1 and this whole expression is un. Now we have to simplify this expression. So this is equals to limit n tends to infinite. So this is 4 raised to n into 4 raised to 1. Then after writing n plus 1 factorial as n plus 1 into n factorial, writing this n plus 1 factorial as n plus 1 in n factorial. Then after this is 2n plus 2 factorial, so writing this term as 2n plus 2, then after 2n plus 1 and then after 2n factorial, because 5 factorial, that is nothing but 5 into 4 into 3 factorial, multiplied by this term So we have 2n factorial in the numerator, and in the denominator we have 4 raised to n factorial, and again n factorial. Now we will simplify this result. You can see that 4 raised to n will cancel out. This n factorial and this n factorial will cancel out. Then after this 2n factorial and this 2n factorial will cancel out. And then after this n plus 1 will be as it is, this one n plus 1 will be as it is, this one 2n plus 1 will be as it is, and this one 2n plus 2 will be as it is, and this n factorial and this n factorial will cancel out. Now taking 2 common from this term, so into bracket we have n plus 1, so n plus 1 will cancel out, and 4 upon 2 is 2. So after simplification we have limit n tends to infinite 2 into bracket n plus 1 divided by 2n plus 1. Now taking n common from the numerator and denominator, we have 2n into bracket 1 plus 1 upon n into bracket 2 plus 1 upon n. Now this n and n will cancel out, and as n tends to infinite, 1 upon n tends to 0. So we have 2 into 1 plus 0 upon 2 plus 0, that is 2 upon 2, and that is equals to 1. Therefore ratio test fails, thus we apply Raabe's test. Now for Raabe's test we will find out un upon un plus 1 minus 1, and un upon un plus 1, that is the inverse of un plus 1 upon un, and that is 2n plus 1 upon 2 into bracket n plus 1 minus 1. Now we will simplify this result. So this is 2n plus 1 minus multiplying 1 by this 2 into bracket n plus 1, so it will become minus 2n minus 2 upon 2 into bracket n plus 1. Now 2n and 2n will cancel out, and 1 minus 2 is minus 1. So this is equals to minus 1 upon 2 into bracket n plus 1. Now un upon un plus 1 minus 1, that is equals to minus 1 upon 2 into bracket n plus 1. Now we will find out this limit, that is limit n tends to infinite n into bracket un upon un plus 1 minus 1, and this is equals to limit n tends to infinite. This n will be as it is, and this result is minus 1 upon 2 into bracket n plus 1. Now taking n common from the denominator, so this is equals to limit n tends to infinite, n into minus 1 upon 2 will be as it is, taking n common, so into bracket we have 1 plus 1 upon n. Now n will cancel out, and as n tends to infinite, 1 upon n tends to 0. So it will become 1 plus 0, which is 1, and 1 multiplied by 2, it is 2. So the overall result is minus 1 by 2. And minus 1 by 2 is less than 1. Hence the given series is divergent by Raabe's test. So in today's lecture we have gone through the statement of ratio test and Raabe's test, and we have seen examples related to these topics. Thank you for watching this video. I will see you in the next lecture.